Define and define. Hackathon, Morales and Google. 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 Define. Hackathon, Morales and Google. Define and define. Hackathon, Morales and Google. Define and define. Hackathon, Morales and Google. Define and define. Hackathon, Morales and Google. 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 Morales and Google.
Welcome back, developers, to another Defining DeFi workshop event. We are here with Axelar again today, and we're going to be doing a cross-chain masterclass on how do we use Axelar with Morales in this hackathon, qualify for that bounty, and build some amazing dApps at the same time. My name's Phil. I'm head of events for Morales, and I'm delighted to be here with you guys today. I am here today joined by Vlad and Jake of Axelar. Let me bring them on stage with us. How are you guys doing today?
Hey, doing great. Thank you. Thank you for having us.
It's our pleasure. We are really excited to get into this. Not very many people know this, but it has been a vision of mine to have dApps that are powered not only by Morales, but also by Axelar as something that we're showcasing and getting excited about and building with over within our communities. So this is very much the realization of something that I've been dreaming about for a large portion of this year, because I am excited about the tech that you guys bring to the table. Of course, I'm excited about Morales as well. And I just hope that everybody who's watching here shares my enthusiasm as we get into it here. I'm going to go ahead and share Vlad's screen here, and we can dive right into it.
Awesome. Are we live?
All right. We can see it now.
Okay, awesome. Hey, everyone. My name is Vladimir. I worked at Axelar. And yeah, basically in this introduction, I'm going to introduce what is Axelar more from a, I would say, technical level, and just give you a quick, some quick tips to how to get started with Axelar. So you probably know it already, but Axelar is a interoperability network. So it's a blockchain built on top of Cosmos SDK. So that means that it's decentralized. It's using the proof of stake. For a lot of people, they think that Axelar is just a bridge, but a bridge is just an application that you can build with Axelar. So you can think of Axelar, what it's doing for cross-chain is a bit like what Ethereum is doing for blockchain. So it allows you to build like cross-chain application. And basically, you can use Axelar for two main use cases, either to transfer assets, transfer tokens from one chain to another chain. And where Axelar actually shines is that it allows you to transfer not only from one chain to another chain inside one same ecosystem, but between different ecosystems as well. So you can have use cases where you can transfer some, let's say, USDC from Osmosis, which is a Cosmos blockchain, to a EVM chain like Phantom or Moonbeam or Avalanche. And it also allows you to build any kind of Turing-complete logic where you can build a truly cross-chain application where the user can interact with it on Ethereum, and something else can happen on another blockchain like Avalanche or Phantom. So how Axelar works is that we deploy a set of gateways on different chains, and you as a developer interact with those gateways. So for instance, if you're building an application that interacts between Ethereum and Avalanche, you're going to build a set of smart contracts on Ethereum and Avalanche, and they will interact with our gateways that you can see here that are deployed per chain that we support. So in this use case, let's say that you're building an application that transfers token from Ethereum to Avalanche. You are going to build a smart contract that is going to call our gateway, and then that call is going to be transported to the destination chain, in this case, Avalanche, through our Axelar network. Is going to be validated and called on the destination chain. So that's kind of the gist of what Axelar allows. And of course, it can be a bridge, so transferring a token, but it can be pretty much any arbitrary functionality, any arbitrary function, and we call that mechanism the GMP, general message passing. More on that a bit later. But so if we are to summarize what Axelar can do for you as developers, first of all, you can send tokens between chains, and you can either use our SDK, or you can use the smart contract layer directly and using the GMP, or you can pretty much write any logic that will interact between any EVM chains that we support. Right now, the GMP only is enabled on EVM chains, but in the future, we are planning to add it to Cosmos chains. So you would potentially be able to call some custom smart contract on Cosmos or chain logic and kind of have some effects happening in another chain in a completely different ecosystem. So we have two main tools that as developers you can use. The first one is the SDK. So the SDK, it has a lot of, it's basically a wrapper around an API, and that API, it mainly allows you to generate a deposit address. So we have actually an application called Satellite that is using that SDK, that is just built on top of that SDK. And nothing stops you from literally using that SDK in your own application and creating bridges. And I'm going to show you an example here. This is Satellite, and this is the mainnet version. So you can transfer some tokens between different chains. As you have seen here, we have different ecosystems. We have something like Osmosis and something like EVM chains. So for instance, what that Axelar SDK allows you to do is to generate this deposit address, and I'm going to do it, generate one here. So if I want to transfer some USDC, Axelar USDC from Avalanche to Moonbeam, I can just call that SDK, and all that UI is doing is just calling that SDK and generating that deposit address here. And then you can just transfer your token to that deposit address, and Axelar is going to relay your tokens to the destination chain. So that's an easy way to kind of build cross-chain asset functionality to your application. And you don't need to have any smart contract logic. It's just purely an API. A deposit address is generated, you transfer fund there, and the funds are being relayed to the destination chain. And for instance, if I copy that deposit address and we have a Axelar chain explorer, Axelar scan is called, you can go there and paste it here. And you will see that we basically have a set of logs, and you can paste the transaction hash here, the address, block, and here I pasted the deposit address. So it logs me that, hey, a link event has been generated. So a link is how we call the fact that we generated deposit address, and we're listening to that deposit address if you transfer some funds. And in this case, it's Avalanche to Moonbeam. And yeah, it's here you can see that a link event has been generated with that recipient address that I have provided in the Satellite app. So that's an example of the use of Axelar through the SDK. And it's just one function. You call it, and you specify the source chain, the destination chain, the asset that you want to transfer, and destination address. And it's going to generate you that deposit address, and you can transfer the tokens there. One nice thing with that deposit address is that it also works with centralized exchanges. So because it's just a deposit address, any wallet, any dumb wallet can actually transfer tokens on that address, right? It can come from an exchange, for instance. So that's actually quite nice. So you can integrate something like a centralized exchange to a decentralized DEX, for instance. The other functionality, and that is available on the gateways. So if I come back to our general kind of architecture here, remember that we have a set of gateways deployed on the chains that we support. Those gateways, for instance, for EVM chains, is basically a smart contract. And that smart contract has different functions. One of them is send token. So as long as the gateway is authorized to send a token on your behalf, and the token is ERC20 compatible token, so you just need to approve it first, approve the gateway to use your token. As long as it's done, the gate will actually forward your token to the destination chain. And here the logic is pretty similar. The main difference here is that this method is using the SDK, so it's just an API call. And this method is using you actually need to program a smart contract, right? So you can if we take the image here, you can write, you can use the gateway to transfer a token from Ethereum to Avalanche or Binance. It's really up to you. But in that case, you need to interact with the smart contracts. So this is
Can you just walk through that flow a little bit more? Because I think that's like really interesting. So you generate a deposit address on the front end of your dApp, right? And then you go plug that into a wallet or a centralized exchange. And then that gets sent and it hits our gateway contracts. And then like, can you just from a high level, like explain what happens on like the network level, where like the network is kind of understanding what that, like, how does the network know where to route that address? Like what happens kind of underneath?
So what happens is that once we generate a deposit address, Axelar will listen to any kind of transfer on that address. It's a bit similar to what centralized exchanges are using when you want to transfer some crypto, right? They generate an address that they only are aware of, and any transfer to that address basically goes in the portfolio, in your portfolio on the centralized exchange. It's a bit different, but with this example, it's just that Axelar generates that deposit address, and we listen to any transfer on that deposit address. And as long as the asset that you're transferring, and you don't have to connect any wallet, you just need to do a transaction on the source chain. So if we go back to that satellite example, here, all you need to do is to transfer some Axelar USDC on Avalanche to that address. Like you can simply trigger a transaction with MetaMask here, and that's it. That's all you need to do, and the transaction will be picked up by the Axelar network, and we're going to deduce the fees because they are like relayer fees, and this transaction is going to be forwarded to the destination chain. So if we go to Axelar Scan, there's a navigation tab here called Transfers, and you can see the main transfers that are happening using that SDK. You see from Juno to Osmosis, someone has transferred 100 USDC, and if you click on that transaction hash, you will see the whole flow of what happened. Here we don't really show the link address generation. We're going to show it soon. So what happens is that first a link event is generated. So an address, a deposit address is generated. Then the user sends the asset to that deposit address, and then Axelar detects pretty much what has happened, and it will forward it to Osmosis, right? And the way it happens is through the mint and burn mechanism. So if I'm transferring some Axelar USDC from Avalanche to Moonbeam, how it works is that those tokens are going to be burned on the source chain and minted on the destination chain, right? So that's kind of the big picture of how it happens. But the nice thing is that since it's an API, you don't really need to care. All you need to care is just generating the deposit address and transferring, and so the user can transfer the funds on that deposit address, and that's it. That's the simplicity of it. You don't need to program anything pretty much. And we have,
I have a follow-up question on that.
Yeah.
Sorry to interrupt, but so when in the first instance that the assets are moved from the origin chain to the destination, you're describing a mint and burn, where they're burned on the origin chain and then minted on the new chain. Now, when should those assets be later returned to the origin chain? Are they? How does that look? Does it look different since the action already took place in one direction? Is it using like a pool that's like maintained of the burned tokens?
Yeah, there's a pool created on Curve Finance, and basically, let's say you transfer some Avalanche to Moonbeam. I'm not going to do it here because it takes a bit of time, and nothing stops you from doing the other thing around. So you can switch from Moonbeam to Avalanche, and the same Axelar USDC can be transferred back, right? By the way, if you want to try with Test Fund, you can go on testnet.satellite.money, and you will have the same application, but on the testnet. And here you can just test it out and see how it works. But the key takeaway here is just that it's basically an API call, right? And it gives you that deposit address, and it forwards the funds to your destination chain. Okay. And so that's for the SDK with get deposit address function. The other way to do it is on the gateway level. So you need to call the gateway smart contract. The function is called send token. And we, of course, have examples of that. We have a repository with various examples, and you can see how it's actually done. But here, just a brief introduction. And so that is for transferring the tokens, right? So we can use the SDK with the deposit address, or the send token function with on the gateway level. I would say the main difference between those two is that this works with Cosmos, and this, of course, does not, because it's a send token on a smart contract, and that means that it's based on the EVM chain, right? So this only works between EVM infrastructures. But if you want to use Cosmos, from Cosmos to EVM, from Cosmos to Cosmos, or from EVM to EVM even, it is possible with this deposit address generation. So the other thing that we offer is the general message passing. So it's a kind of a abstract, universal way to call anything from one chain to another chain. And here we have two functions, again, on the gateway, right? So those gateways, right, they all have those interfaces implemented. For general message passing, you have call contract and call contract with token function. They are pretty much the same, except that call contract with token just instructs the destination smart contract that it can do something with a token, right? And here you call, for instance, on Ethereum call contract, you specify destination chain, let's say Avalanche. You specify the contract address that is going to be the receiver of that cross-chain call, and you encode a payload, which is a ABI encoded payload, pretty much everything that Solidity supports. And on the destination chain, on Avalanche, this payload is going to be decoded, and you can execute any arbitrary function. The call contract with token function is very similar, except that the destination token would know that it can spend a token. And here the token symbol is provided, and the token amount is provided as well. So I will just show you a quick kind of overview of the general message passing. Let's say we can take the example that we had before between Ethereum and Avalanche. So here's Ethereum, here's Avalanche, here's your smart contract on Ethereum, here's your smart contract on Avalanche. And when you're building a cross-chain application, you want the users to call Ethereum, and something will happen on Avalanche, right? So thanks to the general message passing, it is possible your smart contract will interact with our gateway on Ethereum. And once the interaction happens, Axelar network will pick up that transaction and will kind of relay it to the destination chain where it can be executed. Normally, you will have to kind of call the execution of the contract. Axelar does not normally does it for you, but we provide a service called fee service. If you pay the fees before you call the gateway, and the fees can be paid in native tokens or in any token that we support. For instance, you can pay in USDC. We are going to call the logic on the destination chain for you, so you don't have to worry about actually calling the destination smart contracts, because as we know, EVM ecosystems don't have self-executable smart contracts. Someone needs to call them all the time. It is possible in Cosmos, but not in EVM. So that's a utility functionality that we provide with a fee service. So you can be sure that your cross-chain call will be executed on the destination chain in just one function call on the source chain. So that's a very brief introduction about the general message passing. There are some resources that you can consult. The first one is the GMP examples, and I'm going to show you that in a moment. It's just a repository with a lot of cross-chain general message passing example, like call contract with token, an example with NFT. You can view how it's done there on the smart contract and how it's called with JavaScript. We also have another tool called Axelar Local Dev. Basically, when you are working with cross-chain application, you need to test your logic across different blockchains, right? So you need to make a call on Ethereum, and that call is going to be, and something is going to be called on Avalanche or Moonbeam, right? We provide a utility, a library that allows you to quickly spawn those kind of networks on locally, of course, on your computer. So you can write tests, you can test your logic, and behind the hood it's using Ganache. So it just spawns different networks and just a utility, and you can fund some ERC20 on those chains very easily. Otherwise, you need to do a lot of configuration to test your application. Already testing your application on one chain is complicated, but if you add like 3-4 different networks and how to handle that, we provide that pretty much with this library. The SDK I have already mentioned that allows you to generate the deposit address and query the Axelar scan. So it has an API that you can query to get, for instance, the status of the transaction that you have made, right? And we also have the docs. So let me quickly go through the docs. So the docs are very useful, of course. Here you can see in the resource section by networks, mainnet and testnet. You can see what kind of chains we support. You see that here we support 7 chains, and on every chain you see the gateway address and the gas service contract. And remember, the gas service is this thing I showed there that allows that where you can pay for your cross-chain call. So it's executed direct on the destination chain. So this is the address of the gas service, and you can see the tokens, for instance, that we should support and their addresses per chain. The same for the mainnet. And when writing your cross-chain application that is using general message passing, your smart contract will usually reference that contract and this contract, this one to pay for the fees and this one to actually execute the cross-chain transfer. We have a new tool called the Sandbox, and it's available in here, Axelar Sandbox. And it's basically a interactive kind of sandbox where you can quickly test your cross-chain applications. And it's the URL is here, xchainbox.axelar.dev. And here is basically you have 2 smart contracts to really test your your basic smart contract logic. You have a message sender, which is a smart contract that, I don't know if you guys can see here. I'm going to zoom a bit. This message sender on the source chain that references the gateway and the GAS receiver. Remember the two contracts that I talked already about, and the message receiver contract that is also referencing the gateway and the GAS receiver. And basically, it's just a setter small application where you call a function, and that function on the source chain is going to update the value in the smart contract on the destination chain, and you see the value here. So a quick things here is that here's the main function that you are calling on the source chain. It encodes the payload, any arbitrary payload that you pass. It uses ABI encode, and and it can pay the GAS receiver. Remember the service that pays for your that executes your transaction on the destination chain. You need to pay it first before executing the call contract. And here you execute the call contract function on the gateway, specifying the destination chain, destination address, and the payload that actually comes from those arguments. And on the receiver part, the smart contract that's going to receive a call from Axelar, the only requirement is that it needs to implement the Axelar executable interface. So it needs to have this _execute function. And this is for call contract. We have the same function, execute with token, for call contract with token. And that's a specific, like a reserved name, like a callback that Axelar will call on your destination smart contract. And here we decode the ABI that is passed through the payload. And the advantage of that is that you can encode any data that way. And it just logs, it saves the source chain and the source address. And here you can put any arbitrary logic. So you know that this function has been called by Axelar from this chain, from this address, right? So you can really customize how your cross application is working. And this sandbox has a bit of JavaScript here to be able to deploy the contract and call them, right? And you have a set of examples here. We are adding new examples regularly. Right now we have a hello world here, and to test it locally on that machine, you use simulated. You can also connect it to a testnet. Of course, you need to have some testnet crypto to be able to deploy your contract, etc. So for quick testing of your cross-chain application, we recommend using simulated. And all you need to do is to press execute here. And it's going to deploy the smart contract, and you will see a log here that is calling from Avalanche to Moonbeam. And here we go. The cross-chain call is executed. If we just look at the JavaScript here, we basically deploy a destination contract on Avalanche, and we deploy a source contract on source contract on Moonbeam and destination contract on Avalanche, and we basically call that function, which is set remote value on the source chain, right? And we pass the value hello world. So that value from Moonbeam is going to be passed through GMP to the Avalanche, and we can even change the value here. And actually, let me just open here, set remote value. So we see the GMP call here. This call has been done on Moonbeam, and we see the value here that has been passed by that call, right? And we can see the execution of the cross-chain call by Axelar here. You can see the logs that it came from Moonbeam, that the address that called that execute function is this address. Obviously, you can create custom logic that only allows certain address to call that that execute function, and you have the payload that's going to be decrypted by the ABI decode function. And yeah, that's interactive environment that you can use to quickly test your cross-chain smart contracts. And the two repository that I would recommend that you check is the Axelar local GMP examples, and there's the examples and examples web folder. In the examples web, it's a small React application that is linked to some cross-chain calls, and the example is just some CLI examples. You just need to follow the README and run them, and you see this is the JavaScript, and sorry, this is the smart contract that is going to be executed on all the chains. That's going to be deployed on all the chains, and those are like the functions set, remote, and execute. For easiness, we just use the same smart contract that we deploy on all the chains, and they both can kind of call themselves. And it has a lot of examples. It has call contract with token, some NFT functionality, and basically something to get you started to give you the imagination to build cross-chain applications. And the other repository is Axelar local dev. Again, you have the documentation here. It can help you to create EVM networks powered by Ganache to test your cross-chain application, right? And you can easily deploy tokens, like for instance here it's a USDC with six decimals, so you don't need to worry about how the deployment. Everything can be quickly configured for you, so you can just focus on writing the cross-chain logic. Yeah, that's all I wanted to talk about.
I see we have a series of questions in the chat. I'd like to pull up here if we have a few more minutes.
Yeah, let's go.
All right, perfect. So the first one here is, how about cryptocurrency asset transfer? How does the asset value, or how is the asset value determined on the target chain where the contract of the token does not exist? Oh, liquidity also does not exist. So I think what he's asking is, how is the value maintained? And it seems to me that it's maintained because the original asset is always redeemable on the parent chain. Is that correct?
Yeah. So if we go to the docs, where are they? So here's a list of assets that we support here. We don't support assets that are not there, right? So, well, it's actually, we don't support assets that are not there. So all the assets that we support here, we have pools for them that are deployed on all the chains that we support. So for instance, Axelar USDC, it is deployed, it is usable on all those chains. For instance, W wrap it only on this one, and you need to check which assets are supported on which chain, and how the price is determined. Well, via, again, we use pools with Curve Finance, and the idea is that the value is maintained because simply the token on the source chain is burned or locked. You can view it the way you want, and it's minted on the destination chain, right? So you can transfer from Avalanche to Moonbeam the same USDC and back. Of course, you will lose fees that we take for the transfer, but apart from that, the value is maintained via pools.
That leads into our follow-up question here from the same person in the chat, asking, how about the write function on the target chain? How is the gas satisfied in order to mint the tokens on the destination chain?
How is
so when you're there, because it's a mint and burn, as we've been discussing, so you burn on the origin chain, but when you're minting on the destination chain, you haven't paid any gas over there. So we're wondering, how is the gas paid in order to
we cover the gas. We cover the gas, and that's why we have fees, right? So we if you go to satellite.money, if you want to, for instance, transfer from Ethereum, which has quite high gas to Avalanche and you want to transfer USDC, the fee is 11 USDC, right? We kind of take the fee, and it's to pay for transactions, for instance.
That makes sense. All right, next question here. If two contracts on two chains, can GMP be used to verify ownership of tokens from one chain to another chain? Example, verify user's balance of token on chain 1 in a smart contract on chain 2. So I guess what it's wondering, it sounds like this is something that you would do through the Axelar cross-chain messaging protocol. Am I correct?
Yeah. So can you please repeat the use case? Is where from on chain B you want to verify how much a user has on chain A, right?
I think that's what he's asking here. If I'm using chain A and I'm paying gas on chain A, but I want to verify ownership on chain B, how can I do that with Axelar?
Yeah. So on chain B, you have this function called execute, right? That I showed you earlier. Where is it? Message receiver. So that's a smart contract that will be deployed on chain B. Let me close that. And it has this execute function. Literally, you can put any logic here. So you can call a ERC20 on the destination chain to verify the ownership. I'm just trying to think about a use case where you would have to do that. But any arbitrary logic can be called here.
So here's a scenario in which you might need to do that.
Yeah.
If let's say you developed a GameFi dApp. So it's a game, but it also has some token utility. And in order to access the higher difficulty function of the game, you need to prove ownership of a certain number of game assets. Now, those game assets do not need to be on the chain that you're playing the game on. They just need to be on one of the supported chains. So in that case, you would need to check each of the chains that you support to see if the user has assets on those in case they're holding them there instead of the chain that they're actually using.
I guess that can be solved because that can be solved with I guess with the right architecture, right? Because here is the function that is being called on the source chain, and here is the callback that is being called by Axelar on the destination chain. Literally, you can, if you have ownership of those assets on chain A, I guess you should call the function on chain A, right? And that chain A will verify the ownership. And only if the ownership has been proven, only then will it do the cross-chain call.
That makes sense to me. Move on to the next question.
Yeah,
I'm sorry, did you have more to add?
Any logic that you can write in a smart contract, you can just kind of decentralize it. You can write it on different chains. Of course, you have two sides of a chain. You have the source smart contract and the destination smart contract, and they all have access to some data. So yeah, in that case, I guess the easiest way would be to verify the ownership on the source chain or on the destination chain if the ownership is owned on the destination chain. As long as one of those two chains have ownership, it can be verified in this custom function, right? Because the developer has all the freedom to write whatever logic he wants.
Perfect.
Like literally like here, before or after.
One follow-up question on that doesn't really relate to the hackathon we have going on right now because Algorand is not a sponsor, but do you support Algorand currently?
Me personally,
no, I mean the protocol.
I don't think so. The chains we support are listed in our documentation here.
Perfect.
Right. So you can always check the mainnet and the testnet tab and see what kind of chains we support. So those are the IBC chains, the Cosmos ecosystem chains that we support, and new chains are being added regularly. And those are the EVM chains.
All right. Next question here is, I need more secure control of wallet call functions than just someone using a signature key and calling a false call and illegal. I'm not exactly sure what he's asking here. Vlad, does this make sense to you?
No. Maybe that question can be rephrased.
Yeah, if you can go ahead and post again in the chat here, and we'll come back to your question. If you can describe it in a slightly different way, we certainly want to give you a good answer, but just not sure what you're asking there. All right. It's asking about functions that only need to be called by owner only.
Well, nothing stops you from putting that owner only requirement in the function body, right? So if we come back to here, nothing stops you from have a require here that the caller of the function should be an owner, right? So for, I don't know, like, let's say you have an owner, right? And haven't programmed Solidity for a long time. I don't know if that's I think that's the other way. Anyway, it's a bit of pseudocode. So you have the owner here, and it would check, like, I don't know, require message.sender is equal to owner, right? Something like that. So it's up to you to program the logic, the custom logic that you need for your cross-chain application. If you want your cross-chain application to only accept the owner as a caller, or I don't know, the receiver, it's up to you.
So I've got kind of a generic question here about programming a particular type of dApp. I'm going to go ahead and put this one up here because it's not a bad question. I don't know that it relates to Axelar specifically, but Vlad can correct me if I'm wrong there. So generally speaking, you could add an exchange function on the back end, which would do what's being described here. Is it possible to make a betting platform where users can bet in different assets and get the winnings in the same asset as well? Yes, absolutely, that's possible. You would need to build out that logic. Does Axelar have any tools that might help with this type of development?
So the ability of betting on assets?
Not so much that. I think the question here more relates to converting between different assets on the back end. So from the user's perspective. So if you're speaking in terms of cross-chain, Madhav, I think that allowing some cross-chain functionality, Axelar is truly going to be your friend here. But if you're doing this all within the same chain, it might be a little outside the scope of the functions we're discussing now.
I think it's, so are we talking about the conversion of the assets on the same chain?
We're talking about conversion of the user provided betting asset to a different payout asset.
Well, I guess that can be solved with pools, right? So you would just convert on one chain, and like if we don't specifically provide like kind of I would say tools for that, but it's up to you to build it and build it in that way that it would work. For instance, the use of pools can be useful if you want to convert some tokens on one chain to another token, right? If you want to do a simple swap, right? So
yeah, absolutely. And to go a step further, you could, if you're just trying to do this, you could pull the Chainlink shortened boilerplate for AMM v1 and implement that on the back end as part of your dApp, and it could be triggered by the award function. Now, how exactly you do that, that's going to be up to you, and it's maybe not as easy as I'm describing it right now because you're going to have a bit of work cut out for you. But it is totally possible with fully vetted contracts that are in place in multiple instances. And if you want to then make it possible for users to place a bet from multiple chains and have that then take place on the one chain, and then have those bridge functions included. That's where Axelar, I think, really shines.
Yeah, and not only bridges, it can be any call, right? It's like it can be any function call. So it doesn't have to be an asset transfer. Of course, the main use cases right now are bridges and asset transfers, but Axelar, what I want to say that Axelar allows much more than that. You can literally call any Turing complete function on one chain to another.
Interesting.
chain.
So maybe something as complex as placing the bet on whatever chain you want, but then having a specific chain where the bet is paid out might be a cool use of Axelar, because you'd be able to have that bet function include the wrap and transfer function, and then all assets, no matter where they originated, would end up on the payout chain.
Yeah, that could be possible. It's really, I mean, I would say that your imagination is pretty much the limit, and it doesn't, like, smart contract development and Web3 development is still complicated. It doesn't become more easier, but at least it's possible, right? So, and we try to make everything that we can to make it more straightforward, because the advantage of having something cross-chain is that you have access to a larger pool of liquidity, right? So you are not just limited to one ecosystem.
Taking a look at the additional questions here. Oh, it looks like we have a follow-up from our question earlier where we weren't 100% sure where it was going. I think he's asking, is there any way to initiate multiple calls for movement of assets across chains?
Multiple calls. You can initiate several GMP calls inside one function, right? So nothing stops you from this is a question. Nothing stops you from, I don't know, calling the gateway several times and say, hey, this is, I don't know, Avalanche, this is Moonbeam, right? And if that's the question, right? I'm not sure if that's the question.
And if you have additional follow-up questions on this, anybody who's watching the stream right now, we're going to meet in GatherTown in 10 minutes. And that sometimes is a better way for us to go through these really specific use cases. Like if you have you're obviously, everybody for this hackathon is working on their own dApps, and that might lead you down a particular path. And if you want to talk really specifically about that path, I'll be there, happy to talk with you about it. Vlad, you're invited to join us as well if you have time. And that's a great place for us to do some brainstorming and really get down to the nitty gritty on some of these things, because I know that's what it takes to make progress sometimes.
Sounds good.
Well, on that note, Vlad, thank you so much for taking time with us today for this this masterclass and question and answer session. I know that I learned some things that I didn't know about the unique functions and advantages of using Axelar. I encourage everybody who's involved with this hackathon to try it out. Check out these functions, see what you can do. It may be that, you know, the 1 hour you spend today going over what we discussed here ends up becoming a main important portion of your dApp. And that if you never explored it, then you never would have gotten that experience. So take risks, be adventurous. We're here to help you if you get stuck on something. And on that note, click the link in the description. Join us in GatherTown. We're going to be over there in about 10 minutes. And thank you so much to Axelar for being a part of this hackathon event, being our sponsor, and putting on these wonderful workshops with us. We're so blessed to have you guys.
Awesome. Thank you for having us.
See everybody soon.
Bye-bye.